My name is David McAnulty, and this is my video blog of my Coaster Bot build. So one of my big fears in the build is that the CD-ROM drives aren't going to be powerful enough to pull the weight that I'm going to inevitably put on my bot, because I like to add stuff. And it's hard to be frugal with weight, so many toys. So what I'm going to do is take this here chopped off power supply, I'm going to wire it up to my power supply. I only have a single power supply, so it's going to be 12 volt only. So I'm going to have to run the logic board with a 5 volt regulator just so I can test the drives without tearing them all apart. Maybe I find out that, one brand is more powerful than the other. Right, so first thing to do is to wire up the grounds here. I'm going to have a shared ground, so might as well hit them with a little bit of solder so we don't have to worry about our grounds getting wonky on us. You'll notice my fume extractor is me exhaling. I'm going to go ahead and grab a 5 volt regulator out of my power bin here. This is an Arco Mills bin. They're wonderful. I highly suggest purchasing a few and organizing your stuff, and always have a bunch of stock parts like 5 volt regulators because you're always going to need them. Now I'm not sure how much current I'm going to actually pull on the 5 volt rail. I don't think it's going to be much because it's just the logic, but I'm going to go ahead and slap a heatsink on there anyways, because I'm not going to go crunch all the numbers to figure out if this regulator is powerful enough. I have enough of them. If I blow it up, oh well. That's the other great thing about having a lot of extra parts on hand. Now, since this is just a test, I don't want to waste good components. I did waste the 5 volt regulator, but those are hard to find nowadays on things. Everything's 3 volt and lower. So I'm going to pull some caps off this circuit board. I'm going to grab a 47 UF cap just to make sure that the power supply is smooth enough so the logic board on the CD-ROM drive doesn't freak out. Now, I like to use solder suckers. I have braid. I've used it in the past. It's kind of a pain. These things are not that expensive. You can even get the ones that burn, or you can shell out more money and get the silicone ones that don't burn as much. Because I'm too cheap to buy flux. I don't want it around anyways. I have 2 kids. Solder's a little safer. At least I can stop them before they chew on too much of it. Yeah, it's probably good floss. So here we go. Okay, so here's our little circuit that we designed to test our power supplies, or our CD-ROM drives. Gonna hook it up to my wonderful BK Precision eBay find. It's a programmable DC power supply that has an amperage display, which is really handy. Don't have to juggle a multimeter. Alright, so I'm moving from my kind of assembly solder little bits and pieces that could short out nice stuff over to my nicer, what I call my test bench, where I've got all my nice eBay equipment. This here is my power supply, my BK Precision. I'm going to go ahead and set it for 12 volts energy, and I'm going to go ahead and set it for 0.6 amps or 600 milliamps current limiting. That way if something goes wrong, it shouldn't go that wrong. Well, alright, I've got it hooked up with some amazingly wonderful probes that a gentleman here in San Diego was kind enough to donate to me. He wishes to remain anonymous at this time, I believe, but I'll give him a shout out later if he changes his mind. One thing I discovered is that these PC power supply sockets are just perfect for inserting these probes. I can't believe it. I mean, I wish I could get you a better feeling for how strong it's holding it there, but it is like a glove. It's wonderful. I'm gonna have to remember this for the future. So as you can see, we're not pulling any power right now, which makes sense because we don't have anything hooked up. There's no smoke. My capacitor hasn't exploded. Sorry guys, I used a big electrolytic, but I hooked it up correctly this time. No boom. Maybe later. And look at that. We are getting 5.08 volts DC on our red wire, and if we switch it over to our yellow wire, it'd be quite shocking if we got anything other than 12 volts, because we are using that for our source to the regulator, but why not check? And we're reading 12.01 on my ancient fluke. Like you're supposed to, I laid out my plan, my documentation well before I executed on my project. So let's go ahead and start going through the drives and see if some of them work better than others. As you can see, I've got this meter to read the 5 volt, this meter to read the 12, and I've got the power supply itself to show me the current draw. Now that's going to be the current draw for both the 5 volt and 12 volt supplies, but I'm guessing the 5 volt supply is not going to matter much. No fire. Sorry folks. Let's see if it works. Oh, success! I feel very good right now. And look at that. We're pulling 210 milliamps right now just on idle. That's kind of surprising. Gonna have to put this thing on a diet. That is way too much current just for idle. As you can see, our 12 volt rail, once it got a load on it, is nice and super clean. Great power supply. Not that out of calibration as you might think. And our 5 volt rail still running a little high. Oh well. Let's see what happens when we suck the tray in while watching numbers. Ah, do you see that? Little current jump there. Let's eject again. And inject. Reject. Re-eject. So I've raised the power supply to 1.2 amps, twice what I had it set to before. Let's see. Oh, it looks like we are getting constant voltage now. We were slamming into the current limiter before. That's why we were seeing the 12 volt rail drop. That 5 volt rail was holding steady because we had that nice big bolt cap on there. So good thing we stuck that there. Who knows what might happen to this drive. And now the drive's stuck. Huh. That's interesting. Perhaps that's the reason why this drive was in the junk pile. So drive number 1 seems to have died on us. Not surprising, this stuff was in the trash can, or the e-waste bin. So I went ahead and logged it. I also have written drive indicators on the drives because not all of them have clear labels. Let's go ahead and test drive number 2. Hopefully we have better luck. Okay, here's the initial power up of drive number 2. And on. Drive's powered up. Made some groaning sounds. That's a good sign. Let's see if she ejects. Ah, that sounds beautiful. Let's go ahead and watch our numbers when I attempt to do an inject. Not too bad. That sound isn't very promising, but you know, it's not the end of the world. Let's see if this drive has enough torque to do what we need. Okay, here's our scientific test of whether or not the drive has any torque. Well, that wasn't what I wanted. I've improved the rig somewhat. Let's go ahead and try the test again. I'm going to go ahead and watch the numbers the first time. Oops. Help if I powered it up, huh? Oh, look at that. And let's go ahead and show you guys what drive number 2 is actually doing down here. Yep. That's some torque. Let's check out 3 and 4. Okay, and here's the numbers for drive number 3. Powering up the drive. It's not injecting. That's probably not good. We do have a fair amount of current draw though. Last and definitely least is drive number 4. It's white. It's got to be old. No one makes white CD-ROM drives anymore. I also couldn't get it to eject using the paperclip trick, so I'm going to have to go ahead and power it up closed. And whoa, sounds like there might be something in there, folks. There's a copy of Duke Nukem Forever in there, so you know, anyone wants it, drop me an email. Here we go. Inject test of drive number 4 on power up, since that's fair. That's what I did with the other ones. That does just not sound happy. What's wrong, little guy? Well, now it's working. I'm not sure what that was before. Something about the initial power up it didn't like. Let's go ahead and power it up again and see what happens. There it goes. Maybe I had too much twist in the drive tray. This one seems to be working pretty well. I think we have a winner between drives number 4 and drive number 2. And just to point out, you know, you don't want to step 12 volts down to 5 like I'm doing here. That makes a lot of heat. So don't do this long term, guys. It's bad. So recap time. What did I learn from all this? Well, I learned that 2 out of my 4 CD drives are bust. So spare parts, it makes it easier because now I don't need to decide which 2 are the best. I only have 2 that work. I also learned that I should probably make myself a 5 volt supply, a nicer one that can, you know, handle the heat a little bit better. Now I could use 5-volt wall warts, but that's not going to get me the current readings that I want. And yeah, I could use another multimeter, but I've only got two.